Alright, so first we're going to start just with a brief review here of some of these word problems we worked with last week. So on these, if we're given information about the standard deviation and we're asked to find the mean, so here for this first one, we have 3 standard deviations above the mean. So if we start with kind of our general diagram here of our normal curve. So our mean, or x with a line over it, that's the symbol we can utilize for the mean, always goes in the middle. And then we think about those 3 jumps or 3 standard deviations in each direction. So I'm not drawing the curve part on there. So again, we completed these all last week already. So it says she scored a 95, which was 3 above the mean. So that gives me my 95 is up here. Because again, that's 3 jumps above the mean. And the next thing it tells me is the standard deviation, or my S, is 4. So that means for every jump I make, it's a distance of 4. So to move to the left here, we want to subtract that standard deviation. So if I do 95 minus 4, I get 91. Moving another one to the left, I'd subtract 4 again. That would get me to 87. And then our goal is to get to the mean, that middle number, because that's what it's asking us for. So I'd subtract it again and get 83. So to answer this question, you would say the mean is equal to 83. We'll do one more of these. So for this one, we have Richard scored an 88 on his last quiz, which was exactly 2 standard deviations below the mean. So the first one here we had above the mean. This one we have below. So if we start with that same sketch, you could either write the word mean, or I use that symbol, just the X with a line over it. So I have my 3 above and my 3 below. Now you'll notice you could find every number on here, but I'm just following the methodology of finding what I need to answer the question. So it says he scored an 88 and it was 2 below. So the smaller numbers, or below the mean, would be to the left. And it says our standard deviation is 2. So to move numbers to the right, because I want to get to the mean, so if I'm moving to the right on a number line, I want to be adding. So if I add 2 to that, that gets me to 90. Add 2 again will get me to 92. So our mean for that sample, or that problem, was 92. Okay, so there will be some problems on your guys' exam coming up here that look similar to this, where you'll be given a diagram and asked to identify things like the mean. So for question number 1 here, what is the mean? 25, right? So it's that middle number. So that's my mean. There it is. For number 2, what is the mean? Say it out loud. 86, right? It's that middle number. So when we're asked what the mean is, it's just identifying the middle number. So if it's given to us in a diagram like this, again, we just look for it, we see it, we're good to go. Now, in these two, we're given some numbers, but we need to find the standard deviation. So take a moment now and try and solve both of those to figure out what is the standard deviation. So when we find the standard deviation, we are subtracting because it's a distance. So for problem 3 here, I could do 26 minus 17, and I'll find out my standard deviation is 9. You could also do 44 minus 35, or 35 minus 26. You always want to do the larger number first, because standard deviation is always positive. So we never want to get a negative answer there. So again, always do bigger number minus the smaller number. For this one, following the same pattern, I could do 69 minus 64, or 64 minus 59, or 59 minus 54. Either way, you should find 5 is your answer. So, really similar, just kind of a visual versus the description given. Alright, what I want you guys to do right now is, these are similar to what we did last week. Let's go ahead and finish those 4 up right now. Alright, so moving on to our Unit 1 review here. First thing we're going to start with is going to be going through the vocab. So, things I would suggest if I was giving you guys test-taking strategies related to vocab is, pick the ones that are kind of like really blatantly obvious here. So, let's look at the mean. So the mean, we found it a bunch of times. We know it is the average. That's the vocab we've used. So if I'm looking here, bless you, if I'm going through all my answers, I'm looking for something about the average. So I see H right there, the average. So let's go ahead and throw that on there for the mean. I'd also suggest, as you guys have probably done before, crossing stuff out when you've used it, because you never want to write the same letter twice, right? Because that means you're definitely getting one. All right, another really obvious one to me is going to be outlier. right? So an outlier is data that's really different, way higher, way lower. So if we're reading through those multiple choice options there, which one kind of would be an obvious choice for the outlier? I, right? So a data element that is significantly different from the others. Now, if you're someone who's like ready to ace this thing and you can just go in order, that's totally fine. I'm just answering these in terms of like how commonly we see a word, or like how kind of unique the definitions are. Like standard deviation, chances are you guys aren't going to be able to like whip that definition out right off the top of your head. So I'm going to save that one for the end, right? Also on your guys' exam, it's broken up, so it's not all 9 of them together. Like they break it into chunks to make it a little more doable. All right, let's look at the median. So the median, what do we got? What's the answer for the median? Read them around. What do we think? Whoever's whispering, say the answer louder. Yeah. A. Right, so the median is the middle number when the numbers are in order. So again, we've calculated using GeoGebra. That's the definition of it. So the median is just the middle number. What do we got for the mode? Yep. D. So it's the most frequently occurring number in a data set. So again, we talked about how data either has a mode or no mode, right? So there can't be more than one. So here, our mode is the most frequently occurring number. Next one, so the range here. So the range we calculated by doing the maximum minus the minimum, right? So in other words, it's the difference between the largest and the smallest number. So that's going to be choice E. All right, take a minute now. Try and figure out these last 4. All right, number 5 here. So measures of center. We're going to save that one for the end. I want to do qualitative versus quantitative first. So quantitative data, we could find the average. It's a lot of numbers. We can add, divide. And again, we're looking at using numbers to talk about it. So if I'm looking here, choice B says data that is descriptive and not measured. Well, numbers I can measure. So if I look to C, data that can be measured and described using numbers. So that's the definition of our quantitative data. So for number 8 there, that's going to be choice C. Because again, we could find the average. So you can measure it. Qualitative data we can't measure. So if we look at option B there, it says data that is descriptive and not measured. So this is like jersey numbers, yes or no, multiple choice, true or false. So that would be B. Now, if we're looking at our last 2 choices here, we have F and G. So for F, we have the measure of how spread out numbers are in your data set from the mean. And then G, we have measures such as mean, median, mode used to describe the middle or typical value in a data set. So right now, take a look and try to think of which one goes with which. So measure of center, choice G there, because again, it's kind of saying these are the 3 different ways we've looked at our data. And lastly, standard deviation. So we think back to those drawings we just did. The standard deviation is just the distance between chunks of the data. So there, how spread out or how far it is from the mean. So F is going to be for our standard deviation. So on your guys' exam, again, you can expect something really, really similar to that. Okay, moving on to here. So it says for numbers 10 to 12, use the following data set. Now, instead of doing this by hand, we're going to go back to GeoGebra, right? This is how we've done it in the past. So we've done this in different chunks. So we're going to go into GeoGebra, and I'm going to enter in all of my data. I'm just going to freeze this on the board here so I could kind of multitask, and then we'll go back to GeoGebra. By this point, you guys should be incredibly fluent in doing that. So again, I'm clicking those 3 bars on the right side, going to View, clicking Spreadsheet. So type in all your data. Again, on the paper version, I would suggest going ahead and crossing them out as you go. Bless you. You're welcome. Alright, so I've got my data entered in here, so I'm going to go ahead and unfreeze the screen just so you guys can see where I'm at. So as we're previewing here, I know I need a dot plot. Then I need to complete this table down here. And then we're choosing the description of above. So we're going to picture what kind of shape our data takes here. And then we'll see for the next one here we have another problem. So let's go ahead and just start with this one now. So once you have all your data put into GeoGebra, just like we've done probably 500 times in class. Now, do we need another minute to put the data in? Yes? Okay. All right, so just a reminder of how to do this. If I go ahead and highlight my column A, go under here, one variable analysis. Now, so I have a histogram, right? If I want a dot plot, I'd click up here on this little drop-down menu and choose dot plot. And again, on your guys' exam, they're not going to give you quite so much data, but things you want to make sure you include is the number line as well. So if we look towards the bottom of your screen or my screen now, there's numbers on there. So if the test didn't give you them, like if I'm looking here, they have the number line in there, that's awesome. But if those things were blank, you'd want to make sure that you wrote those numbers in. So if there's not already a number line, make sure you include it. But again, kind of copy it down. So just a count. It doesn't have to look as amazingly neat as this, but it'd be great if it did. So again, just make sure we have that going for us as well. So moving on from this now, so what else we needed was our descriptive statistics, right? We need mean, median, mode, range. So the mode we can always pick off from our dot plot. So if I'm looking here, what would be the mode? 5, right? That one definitely occurs the most. If we had to pick a shape of this, is this going to be normal or skewed? Normal, right? Because it's got that hill shape, so it's symmetric on both sides. Remember, skewed data is either majority on the left or majority on the right, and we think backwards. So if all my data is on the left side, I'd say it was skewed to the right. If all my data is on the right side, we'd say skewed to the left. So let's go ahead and fill in what we know. We said our mode is 5. And then for question 12 here, we said it was the normal distribution because it had that nice hill shape to it. There we go. And again, it doesn't have to be perfect, just pretty close. The dot plot, you guys can go ahead and copy that down on your own. We know how to do that. So last 3 things for this problem is finding our mean, median, and mode. So again, to do that, I'm pressing this button right here, the summation with the X next to it for our show our stats. You'll notice when you press that, your graph goes away. So to get it back, you could just click here again. I don't know why it goes away when you click that, but don't panic. It didn't like get destroyed or anything. So for our mean here, so if we round it to 3 decimal places, that'd be 4.964. Our median, we remember GeoGebra actually finds that for us, so that's just 5. And then lastly, to get our range. So here we need to do the minimum and the maximum, and we'll find the difference between them. So if I look at my max and min, my max is 10, and my min is 1. So I would subtract those to calculate the range. So if I did 10 minus 1, I'd find that my range is 9. Alright, moving on. Okay, so we're given another set of data here. So what we're going to go ahead and do is this time we're looking for our minimum, Q1, median, Q3, maximum. It's the exact same steps in GeoGebra. So let's go ahead and throw that in there. Where'd my spreadsheet go? View, spreadsheet. It's in the middle there. Okay. There we go. So again, getting used to dragging and dropping around to find where things are. So again, I'm just going to freeze the screen up here just so I can see that data while I'm typing it in. You guys should be doing the same. So once we get that, same kind of steps here. So we're telling it where to look, using our one variable analysis. Now for this one, we can see there it's just looking for those 5 kind of key ideas right here. So again, we know GeoGebra does that. It does those calculations. So if we go ahead and use our show stats. So something to notice like here, if mine disappears, if you just click this little arrow here, it'll come back. So if you click that, that's where it is. So we have these last 5 numbers here, kind of the go-to for those, right? So I have 0, 1, 4, 7, 10. So 0, 1, 4, 7, 10. All right, so creating our box and whisker plot, we're going to look at it in GeoGebra, and then I'll show you guys as well how to just do that by hand. So here, if I want to see a box and whisker, I just choose this and then choose box plot. So that'll show me exactly where it should be lined up at. And again, you can see on the bottom there as well, there's your number line. But just kind of same amount of effort if we just wanted to go ahead and draw this thing by hand here. So our minimum is that last little dot here, so my minimum's at 0. So you can either draw with a dot at the end or a line through it, either way is fine. My Q1 is at 1. My median is at 4. Q3 is at 7. And my maximum's at 10. So kind of our box part here is in the middle of these. And then we connect to the numbers on the side. So again, same type of picture here. GeoGebra just puts those lines on the side. You're welcome to do it either way. You may use dots or you can use lines. Either one means the exact same thing. Okay, calculating interquartile range. So a reminder for yourself, that is Q3 minus Q1. So I could see my Q3 here was 7, and my Q1 was 10, or 1, I should say. So if I do 7 minus 1, that gives me an answer of 6. So IQR, the interquartile range. So since we checked, we didn't see any outliers in that. Again, just no. And then we checked the upper bound, and we didn't see any outliers out there. So the answer for that would be no as well. So again, if we don't see any of those, we are good to go. And then looking at question 18 here. So we talked a little bit about this last week, but let's get a good example on here so we have it. So we want what percentage of people retweeted 4 times or more. So if I'm looking, I want to see what percent. So when we find a percent, we do the number of things that fit that criteria and divide by the total. So first thing we need to do is figure out how many people fit that category. So it says 4 times or more. So the first thing I'm going to do is count how many people fit that. So 4 or more. So it's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 people that did it. And again, to find percentages, we're dividing, right? So if I see how many total people there are, I had 8, and then let's see, 9, 10, 11, 12, 13, 14, 15. So that'd be 8 out of 15, or 8 divided by 15. And again, where we type those things here is going to be in our input in GeoGebra. So if I did 8 divided by 15, I can see my answer there is about 0.53. So if I wanted this as a decimal, we'd have 0.53. And last week we talked about how to make it as a percentage. So we either move it to the right twice or we multiply by 100. So whichever method you guys prefer, we'd be at 53%. All right, moving on down. Then we got left. Last couple are really easy. Almost done. And again, your test, same types of problems, same type of length. Okay, so for this one, phone's on silent, please. We're given 2 different box plots, and we're just answering some true or false questions about them. So the key idea here is knowing the order. So if we think back to here, our order of those numbers, we had our minimum. So this is our min. This is Q1. This is our median. Q3, and our max. So again, they go in increasing order from left to right. We talked about that diagram a lot when we first introduced box plots, but again, just kind of knowing that, and again, they're the order that they come in, so it's not a surprise. So if I'm looking here, Hampton is our top one, Livingston is the lower one there. So, and it says Hampton and Livingston have the same median. So, look at it right now. Are those medians is the exact same number? Well, here's one of them, right? So it's the middle of this one. And here's this one. Those are definitely not the exact same. If I look to the top one, that's about 700. The bottom one's 800. So I'd have to say false there. So the median is just the middle of each graph. And if we're looking here, those numbers do not line up. So they would literally be like directly on top of one another, like top and bottom of figure of six. All right, next part here, we have Hampton and Livingston have the same IQR. So to calculate the IQR, we're looking at the Q1 and Q3 of each one. So there's for my top one. So those are like the second to last from each side. And I'm looking here, this is my Q1 here, and my Q3 here. So for the top one, if we look here, so these numbers, I have 800 and 1,000. What would be that middle value? What's that one going to represent? So on the number line, what's exactly between 800 and 1,000? 900, right? So I put that there. Between 600 and 800, we'd have 700. So if I want to calculate my IQR, so Q3 minus Q1 for the top one there, that'd be 900 minus 600. So that's going to give me 300. Then on the bottom one, I would be doing 900 minus 700, which would give me 200. So are those IQRs the same? Oh yeah, yes, no, maybe? No, right? They're different numbers. So if they both came out to 100, great, they're the same. But since we got different values here, that one's going to be false as well. And then lastly, really similar to question 20, so it's just calculating the range, so that's maximum minus minimum. So if I did the range for each of these, for the top one, it starts at 1,000, goes all the way down to, well, this would be 500. So for my top one, it'd be 1,000 minus 500, which would give me 500. And then for my bottom one here, it goes up to 1,000 as well. But it only goes down to 600. So I get 400 for my answer there. So again, we see those are different numbers. So that would be false as well. So again, median, we're just looking visually. IQR and range, we're just calculating and saying, are they the same, yes or no? All right. For this one, we have using the histogram to the right. How many cars get 30 mpgs or more? So, key idea here, we're looking at our line of 30. It's our divider. So if I look at this bar directly to the right, how many does that represent? This bar right here, how many does that represent? How many cars are in that category? 2. So that's worth 2. How much are each of these worth? Because I want 30 or more. 1 each, right? So if I add those, what do I get? 4. So 2 plus 1 plus 1. That would give me 4 cars in that range. Question number 23 might be a little tricky here. So again, we kind of talked early on in the unit about the difference between quantitative and qualitative data. So a histogram is used with quantitative data. A bar graph is used with categorical or qualitative data. So this is one just kind of vocab type thing. This one's false, just because, again, they're each used for different types of data. All right, last 3. You should look super familiar from the beginning of the notes today. For number 24, what is the mean? Yes. D, 24. Because again, it's just that middle number. So this is our mean here. Standard deviation we have to calculate. That's the distance between. So it's always easiest, or quickest I should say, just to use these first 2 here. So if I did 29 minus 24, I'd find 5. Good, good. That's our standard deviation. And lastly, similar to what we also started today with and last week, so we have an 87 on his last quiz, 2 standard deviations below the mean. So I'll get the diagram up here. So this is my mean. 1, 2, 3, 1, 2, 3. And it says we were 2 below, so 1, 2 jumps is at an 87. It says our standard deviation was 2. So if I'm going to go to the right on the number line, I have to add. If I'm going to the left, I'm subtracting. So I'm going to add 2. I'd get 89. Add 2 again to get 91. So our answer would be choice C.